Welcome to my YouTube channel, Anveshana Academy. This is Dr. Manjunath Chennappakodu. Dear students, in the previous class, we were discussing about some NEET questions on the international system of units. Dear students, come. Today, we will move towards next problem. I will read the problem first. Which of the following pairs of physical quantities have the same dimensional formula? This is the question which is asked in NEET 2017. Answers are like this. First answer, work and power. Second answer, work and energy. Third answer, force and momentum. Fourth answer, power and force. Dear students, you need to identify the two physical quantities. They are having same dimensional formula. So how to solve this numerical? So first what I will do now. So I will try to list out the dimensions for all the parameters what he has given. So now what I will do here, dear students, the first one I will write it here now. First one, what is the dimensional formula for work? That is, work is equal to, we know already, force into displacement. So what is force? According to Newton's second law, that is what, m into a. Then force distance is, I will write it here dA now. Okay, now I will write the dimensions for all the things. Now what is the fundamental quantity for a mass? Actually that is capital M. Okay, then A is nothing but what? Acceleration, that is nothing but what? Meter per second square. So meter is L, then second square is nothing but what? Time. I will write it here T square. Then what is the distance? Then L actually, dear students. Now then what will happen now? M into L, it becomes L square divided by T square. So therefore what I can do now? I can write work is equal to M into L square. I will take T square to the numerator. Then it becomes what? T to the power of minus 2. This is nothing but what, dear students? This is the dimensional formula for work. Similarly, I need to determine for what? Second one. What is second one now? I will write it here now. Second one. What is power? Okay, power. Second one is power. So the power is represented by what? Capital P. So therefore what I will do? P is equal to, what is power? We know already, rate of doing work. That means work done per unit time. Okay, so P is equal to, what is work done? You already obtained the dimensions for what? Work actually. So that is what? M L square T to the power of minus 2 divided by T is there, dear students. So therefore what happens now? Capital P is equal to M into L square T to the power of minus 2 is there. One more T is there at the denominator. Take it into the numerator. Then what happens? Now it becomes what? ML square T to the power of minus 3, dear students. Now this is what? Dimensional formula for what? Power actually. So second one is power. Next, third one. What is third one? You can torque actually. What is torque now? Torque is represented by notation capital T. What is torque now? T is equal to, what I can do now? T is equal to, again, force into perpendicular distance. You can take small r or capital R. So what is capital M? Sorry, what is capital F? Again, second law of Newton. That is M into A. R, I will write it here. A. Okay. So now what is the fundamental quantity for M? Small m, that is M, capital M, into again what? Meter per second square. I will write it here now. Multiplied with what? Now it is what? R actually it is there. R, I will write it here now. So therefore M, capital M, L into L, it becomes L square divided by T square, dear students now. So therefore what I can do now? So therefore, just a minute. Fine. So therefore what I can do here now? So therefore torque is equal to M into capital M into L square. Denominator T square is there. It will come numerator. Then it becomes what? M T to the power of minus 2. This is what? Answer for what? Dimensional formula for what? Torque actually. Okay, I will block it now. Okay, fine. Next, third one is over. Fourth one. Now torque is over. Energy. What is energy? Energy is nothing but what? Capacity to do the work. Notation for energy, I will take it here, capital E. So E is equal to, again, capacity to do the work. Again, force into displacement we can take, dear students now. What is F actually? Again, M into A into D. What is the fundamental quantity for M? I will write it here, M. then A is nothing but what? Meter per second square, that is L divided by T to the power of 2 into L square. So therefore what I can do now? So therefore E is equal to M into L square T to the power of minus 2, dear students. This is what? Dimensional formula for the energy. Okay, dear students, this is what? Energy. Now I need to write the dimensional formula for force actually. What is force now? So we can write it here now. Fifth term, that is force. Force is equal to, we can take it here. Force is F actually. So what I can do here now? So therefore F is equal to, that is nothing but what? M into A. So we know what is M? Fundamental quantity of mass, that is capital M. A is meter per second square. I will write it here T. Meter per second square is nothing but what? That is M T to the power of minus 2, dear students. This is what? The the dimensional formula for the force actually. Similarly, you write down next. Momentum. What is momentum? You can write it here now. Sixth term, I will write it here now. Momentum. Momentum, I will take it as small p, dear students. So phi is equal to, momentum is nothing but what? Mass into velocity. So mass into velocity, m into v we can write. What is mass actually? So I will write it here now. Capital M, fundamental quantity. The next, meter per second is there. Meter per second is nothing but what? L divided by time is, that is T divided by T is there. I will take it into numerator. It becomes what? T1. So therefore the fundamental dimension for, dimensional formula for momentum is M L T to the power of minus 1, dear students. Now this is what? Dimensional formula for the momentum. Okay, I will mark. Okay, next, what is power? Power already we have calculated somewhere else, the rate of doing work. Force also we know. Now we have calculated the dimensional formula for all. Just we need to cross check the which fundamental quantities they have same dimensions. So first one you can see here now, dear students. So now work and energy. Where is work? Work, what is the fundamental what is the dimensional formula for work actually? M L to the power of L square T to the power of minus 2. One thing. Then power M L square T to the power of minus 3 is there. Hence it is not a correct answer. Okay, dimensions are different. Dimensional formula is different now. Now torque. Where is the torque now? Torque somewhere else you have determined, right? Here is the torque. What is the fundamental dimensional formula for torque? M L square T to the power of minus 2. Okay, one thing. What is the energy? Energy M L square T to the power of minus 2. Hence, energy and torque having both same dimensional formula. Hence, the correct answer is torque and energy. Okay, fine. Now, force and momentum. Okay, what is force and momentum? So force is M L T to the power of minus 2 is there. Momentum L T to the power of minus 1 is there. Hence it is not a correct answer. Then what is power? Power is nothing but what? You can see here now. M L square T to the power of minus 3 is there. But force is M L T to the power of minus 2 is there. Hence it is not a correct answer. Hence what we can say, dear students, now the correct answer for this question is second one. That is torque and energy. Thank you.